Hello scientists, Ty the Science Guy back with another video. And today we're going to be talking about how to make casein, a bioplastic. And today we're going to be reacting white vinegar with milk. More than 8 million tons of plastic are dumped into our oceans each year. Most of these plastics are single use, but stay with us for hundreds of years. Bioplastics are plastic materials that are produced from renewable biomass sources, some of which are better at biodegrading than our current well-known everyday plastics. Bioplastics have grabbed the attention of many scientists in attempts to decrease the negative impact that our current plastics have on the environment, especially our oceans, as well as reduce greenhouse gas emissions. Great, so bioplastics are cool, but what's so special about casein? Well, casein isn't the best bioplastic available, nor is it the most efficient to make, but there's something to be said about making a bioplastic in your own kitchen. Here I'm going to be showing you how to extract casein from milk. Milk contains about 87.7% water, 4.9% lactose, 3.4% fat, and 3.3% protein. The rest are minerals. Casein makes about 80% of that 3% of protein content in milk, while the other 20% contains whey proteins. Let's get right into extracting the casein. Now this is by no means proper lab technique, but I do want to show you guys how you can make casein in your own kitchen. The percent yield and purity will be much lower than if you use proper lab technique. First, a sample of milk is obtained and left out at around room temperature. The temperature is not extremely important, but it does help the precipitation of casein. Then common white vinegar is here as well. We are now going to mix the two. And I'm going to allow this to sit for around 15 minutes to let the casein fully precipitate and settle down. Alright, now that we've let the solution settle for a bit, I'm now going to take and extract the casein from this solution using this apparatus I've made here. This is just a plastic bottle with a paper towel on the top, with a bit of a pocket inside. Alternatively, you can use a coffee filter, but I'm only using this because I know most people will have the paper towel. Here we're filtering out all the rest of the liquid in the milk and taking just the solid casein from the top. While we're waiting for this to continue filtering out, let's talk about why casein precipitates in the first place in the presence of acid. Regular milk has a pH of around 6.5. But when we start adding acetic acid, aka vinegar, we start to reduce the pH. When the pH gets to around 5.5, the casein begins to precipitate out. This is because it starts losing its negative charge. It becomes protonated and therefore nonpolar. At around pH of 4.6, it becomes fully neutral and the net charge of casein is 0. Due to this reason, it's nonpolar and it doesn't react with water, so it precipitates out, as we can see here. The drip rate has slowed down extensively, so I'm going to go ahead and dry out this casein now. Also, fun fact, you may see that this isn't white, but our original milk is. That is because casein creates the white color in milk. And here is where you can start forming the shape that you want for your final bioplastic. Here's the final product, and I will check back with you guys in the morning to see how it hardened.
Although I stated I was going to wait overnight, I ended up waiting a week to ensure that it dried fully. And as you can see, it did crack. This goes to show how brittle casein truly is. But, as you can hear and see, casein is strong and hard, but it is brittle.
Stay safe and stay curious, scientists, and I'll see you in the next video.